This is Regis Algebra 2, Lesson 3.2. It's properly entitled Properties of Linear Function Graphs. I'm just simply saying more on linear functions. So we've been talking about the general form of a linear function, which would be that. We've been talking about the idea that if I were to graph linear functions, here's an example of 3 lines, each corresponding to the same colored equation on the right. And notice what I've done. When in all 3 of these, I have a plus 5, plus 5, plus 5. That means they're crossing the y-axis at the exact same point over here, at the point where y equals 5. But the slope is changing, and what governs the change or the tilt of the line is what the constant that I have before the x. Now here, the constant would be a 1. 1x is the same as x. Here the constant's 3. Which one's steeper? These both go, by the way, in the positive direction, meaning from left to right. As the x value increases, the slope is getting more steep. So we start from here and we move in this direction. That's 1. And we start in here and we move in this direction. And this is a steeper slope. But they're also both positive. They're going up as we go. So these are sloping upward. However, in this last one, where it crosses the y-axis is still the same, but now it slopes downward as we go from left to right here. We're sloping down, and the tilt of that slope is dependent on this value. The fact that we're going down is dependent on the negative sign. The tilt is dependent on the constant. If I had said just negative x plus 5, the angle of tilt would be less. It would be more like that, still going downward. Okay, now I'd like to look at 2 special types of equations. These are where y equals 7. You want to think, where does the y value equal 7? Let's say it's right up here. And it equals 7 there, but what if x equals 1? What does x equal, by the way, for that point? X equals 0. So that point is the point 0, 7. But where would the y value be if x equals 1? It would still be 7. Where would the y value be if x equals negative 1? Well, there is no negative 1 here. So the point is that we want y to always equal 7. So this would indicate a horizontal line. And we call this the y-intercept. In contrast, where x equals 3 here, we would have a vertical line. X would always equal v, no matter what y equals. There is no y in the equation, but it doesn't matter because x must equal y. So we would have this vertical line. So when we have y equal a constant, it represents a horizontal line and gives information on the y-intercept. Where x equals the constant, it represents a vertical line, and we call it the x-intercept, where you could think of it this way, where it intercepts the x-axis right here at 3, where it intercepts the y-axis right here at 7. So that's another idea that we have here. Now let's go on to the next page for a new idea. This would have to do with slope. Is the vertical, sorry, I thought I'd paused it. The run is the vertical, and it is the change, what's changing, the x or the y value, the y value. So this means change in y over change in x. How can I use that idea? Well, let's say I have, another way I could write that, by the way, would be to just say y2. Well, let me do something different here. Let's say this is point 1. It would have an x1 and a y. Can't say right what I'm thinking. And a and a y1. This would be point 2. And it would have an x2 and a y2. So to find the slope, I would take, for my numerator, the change in y, or the rise, and I would say y2 minus y1. To find the run, where the x's are changing, I would take the difference between this x value over here and this x value here. So I would say x2 minus x1. And so this here is just a shortcut up above of writing that. Now going back to our equation, our general equation, y equals mx plus b, this m is the slope. That means the tilt of the line. We showed you that before. And the b is the y-intercept, where it crosses the y-axis. So this gives me a very simple way to graph a line. If my line is of the general format that I have here on the left, let's say I have y equals 2/3 x plus 4. Begin with where it crosses the y-axis, which is the b, and so go up on the y-axis 4, and that's a point. To get my second point, I'm going to go, remember this is rise over run. Or I could say the difference in the y over the difference in the x. Okay. So he likes to show it, and this might help students. He says run over 3, look at the bottom number first, and then up 2. So I'm going to run over from my first point, 1, 2, 3, and then up 2. And that's my second point right there. So my line would look like that. Notice I could have also gone rise. I want to look at the numerator. It's often common to want to look at a numerator. So I would go up 2 and then right 3. 1, 2, 3. And I would still get the same point there. So whichever way you'd like to look at it. Okay. What if instead I wanted to graph this line quickly? I read off the y-intercept, the b, where it crosses the y-axis, so go up 3 on the y-axis, and that's my first point. Now, beginning at that point, I'm going to run over 3, 1, 2, 3, and now rather than going up, I'm going to go down. Why? Because I have a negative 2. So I'm going to go down 2. Oops, not paying attention to my... Down 1, down 2. There we go. And that's my next point, and there's the graph of that line. Now what if I asked you to graph this equation instead? Notice I have x to the first power, y to the first power. It should represent a linear equation, so I'm expecting a line. Now, my general format said y equals mx plus b. So before I can graph this one, go ahead and put it in that form. How would I put it in that form? I would solve for y. So I would take 5x to the other side by subtracting 5x. I'm putting it before the 14 so that it could look more like my form where the x value is before the constant, and then I need to deal with my 7 by dividing both sides by 7. That would give me negative 5/7 x plus 14 divided by 7 is 2. How would I graph it? I would start with my y-intercept, my b, which is 2, 1, 2, plot my first point, and then from there, I'm going to run over 7, run to the right 7, 1, 2, 3, 4, 5, 6, 7, almost running out of space there, and then I'm going to, actually I better squash that down here. Okay, let's just say this is 7 over. I'm going to run over 7, and then I'm going to go up or down 5. I've got to go down 5 because it's negative. So I'll go 1, 2, 3, 4, 5. And that would be my second point. First point, second point, graph the line.